Welcome back. We're now getting to the exciting step of creating a model. How can we do this? Well, we've split our data now, and luckily for us, scikit-learn comes pre-built with some tools for us to use to actually build this model. So what we can do is actually import from scikit-learn different types of algorithms that we can use to create our model. In our case, we're going to use the k-neighbors classifier. But just to show you, if I go to scikit-learn models or model selection, you see that we have a ton of different types of things that we can do. We're going to use the nearest neighbors, which is a very standard, easy to use algorithm. And I'll link to some resources so you can learn more about it. And specifically do the nearest neighbor classification, which is going to do exactly this. It's going to try and divide up the data into different segments. But as you can see here, we have so many models to pick from, or so many algorithms to pick from. And one of the jobs of a machine learning engineer is to actually figure out which algorithm to use. But again, this isn't a full machine learning course, so let's just use the neighbors module. And from there, import the k-neighbors classifier. Hopefully I spelled that right. Now the way the k-nearest neighbor classifier works is we can just use it as a function. And all we have to give it is how many neighbors we want. That is, how many classifications do we want? In our case, we know that there's 3 types of iris flowers. So all I'm going to do is give it the parameter n neighbors of equal to 3. And then finally, we're going to try and fit this data and use this algorithm by giving it the train dataset and the y-train output. So that if I run this, well, nothing comes out of it. Hopefully, we've created our model, but there's no way for us to test it, right? If we go back to our steps, we need to check the output, right? We've created the model. Yes, it's as simple as what we just did, but we now need to check to see how good our model is. How good is our function? Well, we can use the predict now to predict and try out our tests. So we can use the x test dataset and give it to the y_predict variable, which will be our predictions. So what the model predicts based on this new input x test data. Now, the cool thing that we can do now is to actually compare the output of y predictions that our model created with the actual answers. Because remember, we created 4 different data sets, right? We created the train data sets for x and y, and also the test data sets. So for the x test, we gave our new model the test data, which we have the answers to, and the model predicted, so this function was run to try and predict what type of flower might be based on, remember, the columns that we gave it. And now we have our predictions. So we need to compare the predictions with the y test variable. And again, scikit-learn to the rescue has a nice tool for us to do that. All we need to do is from scikit-learn import metrics. And we can now print the actual accuracy of our model. And all we do is say metrics dot accuracy, make sure I spell that right, accuracy score. And the function takes the y test data, which is the correct answers, and the y_predict, which is the predictions that our model made. So if I run this, I get an error because I haven't run the block with the y_predict variable being created. So let's do that and then run this. And there we go. That's our accuracy. Metrics.accuracy score tells us that it's 96% correct. That's pretty amazing. Our model, which we just created in, honestly, 3 lines of code, is 96% accurate. How cool is that? So if we go over what we just did, we imported the data, we split the data into training and test set, we created a model by using the k-nearest classifier in scikit-learn, we checked the output using the y_prediction and y_test variables, and now we got the output. So now we can improve, if we want, our machine learning algorithm. So let's do that in the next video.